Hello, today we are going to learn how to create symbol and footprint for tooling holes for automotive PCBs. So let me give short introduction what exactly tooling holes are on PCB and why they are needed and why shoulder mask is critical for tooling holes in automotive. So these holes here on the PCB panel, this is a PCB panel where multiple PCBs are produced, and here you can see that those four holes which are called as a tooling holes, and on the PCB if you will see there are also these holes which can be a mounting hole or tooling hole. So the difference between the tooling hole and the mounting hole is that tooling holes are non-plated through hole, that which means that there is no plating inside this hole. But in case of mounting hole, most of the mounting holes are having a plated through hole, because those mounting pins they are connected to the ground, so that the case where the PCBs are mounted, that is properly grounded. So that's the difference. Then basically the tooling holes are mechanical reference features. They are not plated, as I said. So these tooling holes are used for the drilling purpose. So what basically PCB manufacturer do, they fix this PCB on this tooling hole, and then after that do the drilling on the PCBs. Then for imaging, then they are used for the shoulder mask processing. The shoulder mask comes in different colors like green, red, blue, white. Then they are also, as I said, that they are also used for the assembly fixtures, which means that for placing the component here, they are used also for that, and then conveyor transport. And the common automotive diameter for the tooling hole is 2.0 till 3.2 millimeters. So it depends, but this is the range normally in which you will find the tooling hole on the automotive PCB. Then here you can see this area is with the shoulder mask. So normally that's not a good idea to have a shoulder mask directly at the edges of the tooling hole. Here, for example, if you will see in this PCB, then you can see some gap. This shoulder mask is not at the tooling hole. There is some shoulder mask clearance is there. So that is necessary. And why it's necessary? Because the reason behind is that the drilling is completed before shoulder mask application, and shoulder mask is later formed around the drill hole using the photo imaging. This alignment is not perfect and always include manufacturing tolerances. And if the shoulder mask openings are defined without shoulder mask expansion, this shoulder mask edge sits directly on the hole boundaries. Here in this case you can see that no shoulder mask clearance here at the edge of the hole. Then what happened basically, it's possible that at the edge of the tooling hole the shoulder mask can sit and it's not properly sticked to the PCB or adhere to the PCB, and during the tooling pin insertion or conveyor handling for the automotive, then automotive the critical is the temperature and the vibration and the mechanical stress which comes on the PCBs. Because of all these factors, these weak mask edges can crack and chip or delaminate over time, and this leads to debris generation and long-term reliability risk in automotive environments. And so that's why it's very important that shoulder mask expansion is critical in case of automotive. There are two things. First one is the shoulder mask. So here what you see, this green color is the shoulder mask, and between this tooling hole and this green area there is a dark green area, and this is that clearance, and that is very important. That is called a shoulder mask expansion. So this shoulder mask expansion, let me zoom in this. So here you can see that this area, so this is called a shoulder mask expansion. What shoulder mask expansion does, moves the this shoulder mask edge away from the whole wall and place it on the stable laminate. So this prevents mechanical damage, accommodates alignment tolerance, and ensure clean tooling pin engagement. And for automotive PCB, as I said, that a shoulder mask expansion of 0.15 to 0.25 millimeter per side on tooling hole is considered best practice, and it's a manufacturing safety margin that protects the PCB throughout its operational life. Yeah, that's why this is very important in case of automotive PCBs. So here you can see the parameters to create the symbol and footprints for tooling holes in Altium. Hole type is non-plated through hole. Hole diameter is 2.1. Then copper pad, it's not a pad, it's a hole. So that's why the copper pad in Altium Designer setting will be 0 millimeter. So it's not an electrical function. Then copper plating, there won't be any. Then shoulder mask expansion, as I said, it should be 0.15 to 0.25 millimeter per side to prevent the chipping and the delamination. Then final mask opening will be around 2.4 to 2.6 millimeter with respect to the hole diameter of 2.1 millimeter. Here the manufacturing tolerances are considered. The copper keep out can be added externally, which prevent accidental pour of the shoulder mask on the tooling hole, and which is minimum is recommended value is 0.25 millimeter. Then paste mask is 0, so anyway we are not going to paste any component on this tooling hole. And then yeah, environment, it's for automotive and harsh environment, vibration and thermal cycling. So then let's move to the Altium Designer, and I will show you how you can create the symbol and footprint. So to create the symbol for tooling hole, open the integrated library schematic. Here I have already opened it, and in the schematic library, let me copy one component. So here I have copied this. Let me change. So it's basically a hole, let's say 2.1 millimeter. Here it's tooling hole. Designator is tooling hole. Comments. Then here in the description, tooling hole for ICT testing in circuit test tooling hole. So tooling 2.1 millimeter tooling hole for ICT. Then in the value in the parameter, remove all this, move all this. Okay, so let me delete this. Let me remove this also. So to create the tooling hole, what you have to do, you have to go to the place, then select the ellipse. We need two. So, oops. One more. Okay, so the first one here, make sure that you have the same grid what normally you use for schematic. I use 100 mil. So here for the symbol, I will also keep the same grid. Otherwise, you know that during the compilation of your schematic, you will get the grid error. Uh, yeah. So to avoid that, make sure that you have the same grid as for your schematic. So here, let me change this, change the color to this light yellow. And here also fill the color to that, and this one radius should be 100 mil, and for this one change the color to black, change this to 80 mil, and this one also, and fill the color here black, and just place it here. Yeah, so that's how the tooling hole looks like. That's all what you have to do to create the tooling hole. So to create the footprint, open the PCB footprint library, and then here in the PCB library, add a component, change the name to tooling hole 2.1 millimeter, and in the description you can add tooling hole 2.1 millimeter for ICT. Here you should choose type as a standard no BOM, which means that this component will not reflect in your BOM. Then go to place here a pad at the reference point. Here in the properties panel, then change it to tooling hole designator, and here no copper for both. Hole size is 2.1 millimeter. Then top paste and bottom paste is not there because copper size is 0. So anyway, we are not going to paste anything here. And then here in the shoulder mask expansion, change it to manual expansion, and here you can change it to, I mean, shoulder mask expansion will be 0.15 to 0.25 from the hole size. So 2.1 divided by 2 is 1.05 plus 0.2 is 1.25. Yeah, should be 1.25. Yeah, that's how it looks like. And then let me see in the 3D. Okay, then here it should not be plated. because it's a tooling hole. So disable this, and so that's how it looks like in 3D. Then let's place a 3D body. For that, what you can do, you can go to the place, choose the extruded 3D body, and then in the properties, you can go by clicking the tab and then choose here cylinder, and this cylinder should be, height will be, you can take off your PCB height, let's say 1.6 millimeter, and radius will be 1.05, and then here in the offset. So let's see how it looks like. Yeah, let me go to the 3D. So that's how it looks like. This is just for the ECAD, MCAD alignment. It's not necessary, but just to make sure that for your assembly documentation, adding this mm, uh, extruded 3D body in cylindrical shape. And that is normally all my 3D bodies are on mechanical layer tile. So I will bring it to the mechanical layer tile, and then what you can do, you can opacity change to 0, so you will not see in the 3D. So in the 2D it is present, but in the 3D you will not see here anything. Yeah. Minus 1.6 millimeter, and then okay, it came exactly at the 3D body. You can see that outside. Yeah, but that you can adjust according to your PC size. Well, it could be 1. Minus 1.6. It could be 1. Minus 1.58. Let me check. Yeah, okay. And then as I said that you don't need it on the 3D body. Then let's integrate it with the symbol. So at the footprint, browse, then here the tooling hole. Okay, okay, and then compile this. So successful. So now let me bring it on the PCB and let's see how it looks like. So go to here, component, and then here tooling hole. Okay, looks good. If you want to disable the value, that you can do here by clicking in the command, so that it will not show you the value. If you want, you can just activate as you wish. And then design, to go to the design and then bring it to the PCB. Validate the changes, execute changes. So it's here. Normally tooling holes are at the corner of the PCB, and they are minimum 1 to 3 millimeter away from the edge of the PCB. Report the polygon, and here you can see in the 3D how it looks like. So now what we can do to provide here the electrical clearance, I will go to the design, then classes. So let me see whether the tooling hole is already present in the classes or not. In case not, then you can, in the component classes, add a class. Let's call it tooling hole. And then here, this tooling hole you can bring under this class. Okay. And then what we will do, we will add a design rule. So here, under the electrical clearance, add a new rule. And this is clearance tooling hole. And here we will add a custom query component class, and tooling hole you can select here, and we will change all this to 2 millimeter, let's say, instead of 0.3. So select all this and then change it to 2. apply. Okay, I have to remove this too. That's why getting the error. Now apply. Okay, and then so here you can see that it has cleared the copper around this tooling hole. So I make it 2. We can again, let's adjust this, bring it to, instead of 2, let's say 1, or sorry, select all this first and then let's make it to 1. Yeah, apply. Okay, report. So that's how it looks like in the PCB. So that's how it looks like, and that's how you can create the tooling hole for the PCB panel as well as for your PCBs. Thank you very much.